A baby is staring at you right now. Not glancing, not scanning the room, not getting distracted by the dog or the light coming through the window. Just locked onto your face with the kind of focused, unblinking intensity that makes fully grown adults shift in their seats and wonder what, exactly, they did wrong. Most people laugh it off. Wave back. Make some embarrassing noise, hoping something changes. But for the last 20 years, developmental neuroscientists have been trying to understand precisely what is happening inside that small skull during those long, motionless stares. And what they found doesn't just change how you see babies. It changes how you understand the human brain itself. Start with the obvious explanation. Babies stare because their vision is limited, and faces happen to be the most visually stimulating thing nearby. That sounds reasonable. Newborns do have a restricted focal range, roughly 8 to 12 inches, which is almost exactly the distance from your arms to your face when you're holding them. So of course, they look at you. You're the only thing in focus. Except that explanation falls apart completely by month 3. At 3 months old, a baby has enough visual range to look at virtually anything in the room. The ceiling, the curtains, the dog is sleeping in the corner, the pile of unfolded laundry you've been meaning to deal with for 4 days. And they still choose your face. Every single time, they come back to your face. That isn't limited vision. That is a preference. A deliberate, repeated, consistent preference. And when researchers started pulling on that thread, what they found in the data was something nobody in the field anticipated. In 2017, a research team at the University of Cambridge published a landmark study in the Proceedings of the National Academy of Sciences. They used a technique called functional near-infrared spectroscopy to measure neural activity in both infants and adults during live, face-to-face interaction. What they were specifically looking for was brainwave synchronization between two individuals. What they found stopped the field cold. When a baby locks eyes with you, when that stare actually happens, their brainwaves begin to synchronize with yours. The same frequencies, the same rhythms, firing across two entirely separate brains at the same time. The researchers tested the effect from every angle. When the adult looked away, the synchronization disappeared. When the adult held a neutral, non-responsive expression, there was partial coupling. But mutual gaze, genuine eye contact, produced the strongest neural synchronization the team had ever recorded between two people of different ages. Your baby is not just looking at you. They are latching their developing brain onto yours. Using your neural patterns as a kind of living scaffold, a real-time template for how a human brain is supposed to function. That stare is not curiosity. That stare is not boredom. That stare is how the human brain teaches another human brain how to be human. But here is where it gets genuinely strange. Because babies don't stare at everyone the same way, the difference reveals something researchers did not expect to find. A team at Harvard Medical School ran a deceptively simple experiment. They showed 3-month-old infants' two faces side by side. One was a stranger. The other was the infant's primary caregiver. The babies consistently looked longer at the stranger, which seems completely backwards until you understand the mechanism behind it. Cognitive scientists call it the violation of expectation response. Infants spend longer looking at things they haven't yet fully processed. The stranger is an unresolved problem. Novel, uncharted, still being filed. By 3 months old, a baby has already spent thousands of cumulative hours analyzing that face. Every expression, every micro movement of the brow, every subtle shift in tone. They're not confused by it. They're reading it. Researchers at the University of Washington confirmed that by 5 months, babies can reliably distinguish between a genuine smile and a performed one. By 6 months, they are actively tracking your emotional state in real time and using it as a guide for how to respond to the world around them. Developmental psychologists call this social referencing. You look frightened. They freeze. You look delighted. They reach for the object. You look calm. They explore. The stare isn't adoration. It isn't idle fascination. It is systematic data collection. Your baby is building a live emotional map of your face and using it to calibrate their own internal understanding of what is safe and what isn't. You are not just their parent. You are the external hard drive for their developing nervous system. Now there is an experiment I need to tell you about because it is one of the most important pieces of evidence we have for understanding what this stare actually means to a baby. And it was considered so unsettling when it was first run that it sparked years of ethical debate in developmental psychology. It is called the still face paradigm. Designed in 1975 by Dr. Edward Tronick at Harvard, the setup is almost insultingly simple. A mother interacts naturally with her infant, talking, smiling, responding. The baby is engaged, happy, locked onto her face with complete attention. Then, on cue, the mother goes completely blank. Still face. No expression. No response. Eyes open, present in the room, but nothing behind them. What happens in the following 90 seconds is one of the most studied sequences of infant behavior in the history of developmental psychology. The baby notices immediately. They try to re-engage her. Big smiles, pointing, vocalizing, all the signals that reliably work under normal conditions. Nothing comes back. They escalate. Bigger gestures, more urgent sounds. Still nothing. Within 90 seconds, the majority of infants begin showing measurable physiological stress responses. Cortisol rises. Heart rate increases. Some cry. Others go quiet in a way that is somehow worse, withdrawing into a kind of flattened blankness that mirrors the mother's expression back at her. When the mother re-engages, recovery begins. But it is not instant. It takes time. What Dr. Tronick concluded from 2 decades of running this study is this. Babies are not passive recipients of care. They are active participants in a continuous, ongoing emotional conversation. And that conversation is conducted almost entirely through the face. The stare is not admiration. It is not confusion. It is communication at its most fundamental level. Your baby is speaking to you with their eyes, and they need you to speak back. There is one more layer that rarely makes it outside of academic journals, and it is possibly the most significant thing on this list. Researchers at MIT's Department of Brain and Cognitive Sciences have spent years studying what is actually being constructed inside the infant brain during all of this face-to-face interaction. And what they found reframes everything we thought we knew about how intelligence develops. Babies who receive more contingent interaction in the first 6 months, meaning interactions where their cues are actually noticed and responded to in real time, show measurably greater development in the prefrontal cortex. That is the region of the brain responsible for planning, decision-making, emotional regulation, and complex social behavior. The architecture of adult intelligence. The hardware that will run your child's mind for the rest of their life. Every time you hold their gaze, every time you mirror the expression you see on their face, every time you respond to what their eyes are trying to tell you, you are not just bonding. You are doing construction work on a brain that will still be using what you built here 40 years from now. So now the warning, because there is one. If you notice a baby who doesn't stare, who consistently avoids eye contact rather than seeking it, who doesn't track your face when you move, who seems to look past you rather than at you, that is not a quirk to wait out. Reduced or absent gaze behavior in infancy is one of the earliest observable indicators that researchers associate with atypical social development. It does not mean something is wrong. Every baby develops on their own schedule. But pediatric neuroscientists are consistent on this point. Early identification changes outcomes in ways that later identification cannot replicate. The brain's plasticity in the first 2 years of life will never be that high again. Intervention at 6 months produces results that the same intervention at 2 years simply cannot achieve. If something about the stare, or the absence of it, doesn't feel right to you, trust that instinct. You are almost certainly the most finely calibrated instrument that exists for reading your specific child, because you have been doing exactly that since the first hour after they were born. So the next time a baby fixes their eyes on yours from across the room and simply holds them there, remember what is actually happening beneath the surface of that moment. Their brain is reaching out for yours. They are using your face, your expressions, your emotional responses as the raw material from which they are building their understanding of the world, of what is dangerous and what is safe, of what it means to feel something, of what it means to exist among other people. 15,000 years of human evolution did not give babies those wide, round, irresistible eyes by accident. Those eyes are the most sophisticated social interface ever developed by any species. And when one locks onto yours, the only correct response, neurologically, developmentally, and in every other measurable way, is to stare back. If this changed how you see the babies in your life, subscribe and leave a comment below. I want to know, was there a moment where a baby's stare stopped you completely? Because if there was, you now know exactly what was happening in both your brains at once. And if you want to understand why babies laugh at nothing, at empty corners and bare ceilings at 3 in the morning, at something only they can see, that is the next video. And the science behind it is stranger than any explanation you have heard before.